So now let's look at some problems that involve mass as well as moles. So our problem here says what mass of hydrogen, so I'm going to circle that, can be produced by reacting 6 moles of aluminum, I'm going to underline that, that's my given, with hydrochloric acid. So I need my balanced equation, so here we have our balanced equation. Okay, so let's label that equation. 6 moles of aluminum is going to go right here, and we are looking for mass of hydrogen. So we're looking for grams of hydrogen. So in this case, for our conversion factors, we are going to need the molar mass for hydrogen because we need to find grams of hydrogen. So when you have grams, you're going to need molar mass. So the molar mass of hydrogen is 2.016 grams per mole. Okay, so that's our molar mass. We don't need it for aluminum because it's already in moles. So 6 moles is what we start with before our reaction takes place. So we put our 6 moles in our moles before box. And remember that we start with 0 moles of hydrogen. Now we're going to do our change during our reaction, which is our mole fraction. Okay, remember those numbers come from your coefficients. And we know that we're going to end up with 0 moles of aluminum. So we're going to lose all 6 moles and end up with 0 moles of aluminum. For hydrogen, we're going to gain, now our mole fraction is going to be 3 over 2. 3 because that's the column that we're in, 2 because that's the moles of aluminum. And then we're going to multiply by our moles. Now remember that that comes from setting up 3 moles of hydrogen to 2 moles of aluminum equals x over 6 moles of aluminum. And when we cross multiply, you'll notice that you get 3 times 6 divided by 2 equals x. Alright, so in this case, x is going to equal 9 moles. Now this is not our final answer because our answer needs to be in grams. So we must convert those moles to grams. So I'm going to use a different color here. So we know that 1 mole of hydrogen is 2.016 grams of hydrogen. We know that we have 9 moles over x. So to solve for that, you can see that we multiply. So our answer, and I'm going to round this, is going to be 18 grams of hydrogen are produced from 6 moles of aluminum. So our answer here is 18 grams of hydrogen. So our next problem, we're going to do 5.3 grams of aluminum chloride, make sure you get all of that, are produced. How many moles of hydrochloric acid were needed? Okay, so 5.3 grams of aluminum chloride, here is my aluminum chloride. Moles of hydrochloric acid, HCl, is hydrochloric acid. So that's how we label our equation there. Now because we have grams here on aluminum chloride, we are going to need to know our molar mass. So that is 133.33 grams per mole. So we have our molar mass now. Now let's look at what we need. Now remember that this MB stands for moles before the reaction. So we actually have no moles of aluminum chloride. We're going to be looking for the moles of hydrochloric acid. Okay, so we know that at the end of our reaction, let me grab a pen, we are going to end up with 0 moles of HCl. All of our moles of HCl are going to be used up. Okay, so we got to work our way backwards a little bit here. So we know that if we produced 5.3 grams, we can convert grams to moles, and that'll give us our moles after. So if we set up our problem, 1 mole of aluminum chloride over its molar mass is going to equal X over 5.3 grams. Okay, so we're solving for X here. So I can tell you that X is going to equal 0.03975 moles. And I carried that out a little far. So we know that to get 0, or to start from 0 and get that number, our fraction is 2 over 2, because there's our coefficient, times our number of moles, and then we end up, we started with 0. Alright, so we're going to work our way backwards here. So the change during the reaction for HCl, we're going to use our 6 here, and we're going to use the 2 from aluminum chloride. We're going to multiply that by moles. Remember, everything is a mole ratio, so we always have to multiply by those moles. So when we do our math here, we end up with 0.119 moles of HCl. And this is actually our answer. So the way we would write that out is 0.119 moles of, HCl are needed to produce 5.3 grams of aluminum chloride. Alright, let's look at another example. Now, for this example, we're going to read our problem again. What mass of carbon dioxide, so mass of carbon dioxide is what we're looking for, is produced by the complete combustion of 100 grams of pentane? So we have our balanced equation here. So mass of carbon dioxide, mass is grams. So I'm looking for mass of carbon dioxide if I have 100 grams of pentane. Now, by our reasoning, we can figure out which one of these things is pentane. We know H2O is water. We know CO2 is carbon dioxide. We know oxygen is O2. So this one must be pentane. And there's a decimal point here because this is exactly 100 grams of pentane. That makes those numbers significant. So don't worry about that. So if we have grams of pentane, we are going to need the molar mass. If we have grams of CO2, we're going to need the molar mass of that one too. So just to move things along, the molar mass of pentane is 72.146 grams, and the molar mass of CO2 is 44.01 grams. So the first thing we need to do is get moles. We've got to convert 100 grams of pentane to moles. So 1 mole, and I'm just going to call this PEN for pentane instead of writing C5H12, is 72.146 grams equals X over 100 grams. So when you solve that, you end up with 1.386 moles. Now, because CO2 is a product, of course we start with 0 moles of product. Alright, so now we need our mole fractions. Okay, so for the pentane, it's going to be 1 over 1 times our moles. So we're going to end up with 0 moles of pentane after the reaction is finished. For our CO2, it's going to be 5 over 1. 5 from the CO2, 1 from the pentane. And we're going to multiply that by our moles. So when we do this math, we're going to do 5 times 1.386. You end up with 6.93 moles of CO2. Now our question asks us for mass, so we're going to have to convert our moles to grams. Okay, so 1 mole of CO2 is 44.01 grams. We know that we have 6.93 moles over X. So when we do that math, you end up multiplying the moles times the molar mass. Your answer ends up being 305 grams of CO2 are produced from 100 grams of pentane. One more practice problem. How many grams of chromium-3 chloride reacting with silver nitrate are required to produce 75 grams of silver chloride? So we have our balanced equation. So silver chloride is AgCl. So we have 75 grams of silver chloride being produced. And our question says how many grams of chromium-3 chloride. So this CrCl3 is chromium-3 chloride. So we're looking for grams. So because we have grams, we do need our conversion factors as molar mass. So for chromium-3 chloride, that is 158.35 grams per mole. And for silver chloride, that is 143.35 grams per mole. Now we need to convert grams to moles, and we need to figure out our moles before. So of course we start with 0 moles of silver chloride, which means we can figure out how many moles after our reaction. So if we convert this to moles, we do 1 mole of silver chloride is 143.35 grams. That equals X over 75 grams. So you end up dividing 75 by 143.35, and that is going to give you 0.523 moles of silver chloride. So the fraction there would be 3 over 3 times 0.523. Of course, we started with 0. Now let's work on our chromium-3 chloride. So moles after we know is going to be 0. We're going to use that up. Our fraction here is going to be 1 from here over 3 from our given times our moles. So when we do this math, we divide by 3, and you end up with 0.174 moles. That's what you started with. Now notice our question wants it in grams, so we must convert. So let's do this in a different color for you. So 1 mole of our chromium-3 chloride is 158.35 grams. We have 0.52, oh, I'm sorry. Oh, let me fix that. We have 0.174 moles over X. So notice that you multiply, and you should start to see some patterns here that you can use. So when we multiply that, our final answer is going to be 27.6 grams of chromium-3 chloride are needed to produce 75 grams of silver chloride.